say we had 6 plus 3 and 2 over 3. So how would we add these two numbers? Well, first of all, notice that 6 is a whole number and 3 and 2 over 3 is a mixed number. Okay, so whenever we have this case where we have a mixture of a whole number and a mixed number, what we do is basically, first of all, we add the whole number components. So we add the 6 and the 3 to give us 9, and then we rewrite the fraction component of the mixed number. So 2 over 3. Okay, if there was another fraction attached to the 6, we would have to add that to the 2 over 3. But in this case, since there's only one fraction, the 2 over 3, with the 3, we can just rewrite it. Okay, hopefully that makes sense, because we're basically adding 6 whole units of something and 3 whole units plus 2 over 3 so we're basically adding 6 whole plus 3 and a bit to get 9, because we add the 6 and the 3, so that's where we get the 9 from, and then 2 over 3, which is left over from the 3, we attach it to the 9. So the answer to this problem is 9 and 2 over 3. So let's look at another problem. So let's say we had 7 and 1 over 4 plus 2 and 2 over 4. So in this problem, we do the same thing. So we first add the whole number components. So 7 plus 2 is 9. And then we have to add the fraction. So 1 over 4 plus 2 over 4. Okay. So how do we add these two fractions? Well, since they have the same denominator, 4, we can just add the numerators together. Okay. So this would give us 9. And 1 plus 2 is 3. So that would give us 3 over 4. So 9 and 3 over 4 is the answer to this problem. So let's move on to another problem. So let's say we had 5 and 3 over 4 plus 2 and 1 over 3. So how would we do this problem? Okay, so same thing. We add the whole numbers first. So 5 and 2 gives us 7. And then we have to add the fractions. So 3 over 4 plus 1 over 3. So in this case, we have to add these fractions, right? But they don't have the same denominator. So what we have to do in that case is, because we can't add these without having the same denominator, so what we have to do in this case is find a lowest common multiple of these two numbers to rewrite these two fractions. Okay, so to find the lowest common multiple, we write multiples of these two numbers. Okay, so what are the multiples of 4? 4, 8, 12, 16, 20, and we can keep going, right? And then what are the multiples of 3? 3, 6, 9, 12, 15. So once we've written the multiples of the two numbers, we have to find the common multiple, the lowest common multiple. Okay, so how do we find that? Well, it's basically the number that appears in the first row and the second row. Do you see a number that appears in the first row and the second row? It's 12, right? 12 appears in the first row and the second row, so that means it's a common multiple of 4 and 3. Okay, and more specifically, it's the lowest common multiple. Okay, because if we keep going, if we continue this list, we could also have other multiples, right? And those would also be multiples of 4 and 3, but we're looking for the lowest common multiple. So that's why we choose 12 as the lowest common multiple. So 12 is our lowest common multiple. So that means we have to write both of these fractions as a denominator of 12. Okay, so we have to change 3 over 4 into something over 12 and 1 over 3 into something over 12. Okay, and basically to find this number, it's not a guess. It's a specific number. So how do we find this number? Well, what do we have to multiply 4 by to get 12? We have to multiply 4 by 3, right? So we have to multiply 4 by 3. Okay, so once we know what we have to multiply this denominator to get 12, we just multiply the numerator by the same number. Okay, so we have to multiply the numerator by 3 as well. So 3 times 3 is 9. So the numerator for this is 9. Okay, so what about this fraction? So what do we have to multiply 3 by to get 12? We have to multiply 3 by 4 to get 12. So we do the same thing to the numerator. We have to multiply 1 by 4, okay, to get 4. So now we've converted the 3 over 4 into a 9 over 12 and the 1 over 3 into a 4 over 12, okay? So now since these have the same denominator, we can easily add them. So we get 9 plus 4 is 13 over 12, okay? And we can't forget the 7 because 7 we get from the 5 and the 2, okay? So we have 7 and 13 over 12. So we're almost done, but there's not a problem, but usually we don't write our final answer as an improper fraction. Improper fraction. You might have noticed that this is an improper fraction because we have our numerator is larger than the denominator. So what we can do in this case is convert this improper fraction into a proper fraction or a mixed number, okay? So how do we do that? Well, we have 7 and 13 over 12 we can rewrite as 12 over 12 plus 1 over 12, right? Because 12 plus 1 is 13, which is there, and then we have the 12 as a denominator. So basically what I did is I rewrote 13 over 12 as 12 over 12 plus 1 over 12. Okay, so 12 over 12 is 1, and then we have the 1 over 12. Okay, so 13 over 12, you can think of it as being the same as 1 whole and 1 over 12. Okay, so we have 7 and 1 plus 1 over 12. So altogether, what do we have? We have 7 plus 1 plus 1 over 12. So altogether we get 7 plus 1 is 8 and 1 over 12. So this is our final answer. Okay. So let's move on to a subtraction problem. So our subtraction problem, let's say we had 3 and 1 over 2 minus 1 and 1 over 5. So the same rules apply to subtraction as addition. So we do the same thing. So first of all, we subtract the whole number. So 3 minus 1 is 2. And then we move on to the fractions. So 1 over 12 minus 1 over 5. Okay. So, this was supposed to be a 2. This is a 2. Sorry about that. And then this is a 2. I'll just erase it and rewrite it for clarity. Okay, so we had 3 and 1 over 2 minus 1 and 1 over 5. So again, we subtract the whole numbers to give us 2, and then we have to subtract the fractions. Okay, so we have 1 over 2 minus 1 over 5. Well, the denominators aren't the same again, right? So that means we have to find what? We have to find the lowest common multiple. Okay, so I'm not going to do the whole procedure of finding the lowest common multiple again just to save time, but the lowest common multiple of 2 and 5 is 10. So I can rewrite these fractions as 5 over 10 minus 2 over 10. Okay, so now since the denominators are the same, I can just subtract the numerators. So I get 5 minus 2 is 3. So I get 3 over 10, and then I have the 2 out front. So my final answer is 2 wholes and 3 over 10. Okay, so that's everything you need to know about how to add and subtract with using mixed numbers. There is another method that you could use. So I'm going to cover that as well in this video. So let's say we had the first problem that we did, 6 plus 3 and 2 over 3. So another method you could use to add this mixed number, to add these two numbers, is first convert all the mixed numbers into improper fractions. Okay, and then basically add the fractions after. So what do I mean by that? Well, first convert all the mixed numbers into an improper fraction. How do we convert a mixed number into an improper fraction? Well, we have to multiply the whole number by the denominator, and then we add the numerator. Okay, and that gives us the numerator of our mixed number. So we have to multiply 3 by 3. So 3 times 3 is 9, and then we add 2, so that's 11. So that's 11. And then to get our denominator, it's the same denominator as in the fraction, so it's 3. So the equivalent improper fraction of this mixed number is 11 over 3. Okay, so just to make sure you guys understand exactly how we do that, I'm just going to do another example. So let's say we had 2 and 1 over 8. How do you convert this into an improper fraction? Well, you'll multiply the 2 by 8, right? And then add 1. So 2 times 8 is 16. And then you add 1. So that's 17. And then for the denominator, you keep the same denominator here. So the equivalent improper fraction of 2 and 1 over 8 would be 17 over 8. Okay? So now going back to our problem, we have 6 and 11 over 3. So the whole point of this was to convert the mixed number into an improper fraction. So the next step is to just add these two numbers as you would any fractions. Okay, so 6, we can rewrite it as 6 over 1, right? Because we can rewrite any number over 1. And then you just add these two numbers like you would anything. So the first thing you should notice is that these denominators are not the same. So we need to, again, find the lowest common multiple. So again, I'm not going to go through the whole process, but the lowest common multiple of 1 and 3 is 3. And when we do that, we are going to get 18 over 3 plus 11 over 3. Okay, so now since we have the same denominator, we can just add the numerators together. So we have to add 18 plus 11, which is 29. And then we keep the denominator, 29 over 3. So our answer is 29 over 3. And you may notice that this is an improper fraction, right? So one thing you can do is you can leave this as an improper fraction, or you can convert it into a mixed number. Yes, you can convert this into a mixed number. So how do we convert this into a mixed number? Well, how many times does 3 go into 29? 9 times, right? You can put 3 into 29 9 whole times, and with some left over, because 9 times 3 is 27, and 10 times 3 is 30, right? So the most we can put 3 into 29 is 9 times, okay? And how much do we have left over? Well, 9 times 3 is 27, so we have 2 left over because we have 29 on the top. So we have 2 left over, and that's over 3. So basically, to convert from an improper fraction to a mixed number, we basically determine how many times does the denominator, go into the numerator, so 9 whole times, and then however much is left over, in this case 2, we write that over the same denominator. Okay, so let's just do another example just to clarify that, just so you guys are 100% on how to do this. So let's say we had 15 over 2. So how do we convert this into a mixed number? Well, how many times does 2 go into 15? 7, right? 7 times. So 2 goes into 15 7 times, and there's some left over. So what's left over? So 7 times 2 is 14. And to get 15, there's 1 left over. So if there's 1 left over, we write 1. And then the denominator is the same as the denominator here. So whenever I say, how many times does 2 go into 15, I mean how many times does it go into 15 without going over 15, okay? Because if we had, for example, 14 over 2, how many times does 2 go into 14? Well, it goes into 14 7 times exactly, right? And there's nothing left over. So our answer would just be 7. But in this case, 2 goes into 15 7 times, but there's something left over. That something is our fraction. So we can rewrite 15 over 2 as 7 wholes and a half.